Hi there. This video is about prime numbers and factoring. Our first objective is to factor numbers. We have that whole number factors of a number, divide that number evenly, meaning there is no remainder. 1, 2, 3, and 6 are whole number factors of 6 because they divide 6 evenly. And you can see a little picture here that represents that. We know 1 goes into 6 times, 2 goes into 6 3 times, 3 goes into 6 twice, and 6 goes into 6 once. This tells us that both the divisor and the quotient are factors of the dividend. Just as a reminder, the number out here, this is what we call the divisor. Our answer here of a division problem is the quotient. That means that the number inside the division is what we call the dividend. And as that note says, the divisor and the quotient are factors of the dividend. To find factors of a number, try dividing the numbers 1, 2, 3, 4, 5, and so forth. And the numbers that divide that number evenly are factors. So meaning if we start with a number and try to divide it by 1, 2, 3, 4, 5, and so forth, if it goes in evenly, it is a factor. So here's your first example, and you can see it's already done for you. If we have to find all the factors of 42, we start by taking 42 divided by 1, which comes out to exactly 42. That tells us that 1 and 42 are factors. If we divide it by 2, we get 21, so we know 2 and 21 are factors. Divide it by 3, we get 14, therefore 3 and 14. Now, if we do 14 divided by 4, and if you need to use your calculator to help you, feel free to do so. We're getting a decimal, which tells us that 4 is not a factor. We know 5 does not go into 42 evenly. We notice 6 does 7 times, and we notice 7 does 6 times. Once we start repeating our factors, we know we found all the factors of 42. So let's look at one together. So find all the factors of 30. So I'm going to start with 30 divided by 1, we know is 30. Therefore, from that, we know that 1 and 30 are factors. Let's try 30 divided by 2. Well, that comes out to 15. So that tells us that 2 and 15 are factors. Let's keep going. After 2 is 3, and we're getting a 10 there. So that tells us 3 and 10 are factors. What about 30 divided by 4? Does that go in evenly? No. What about 30 divided by 5? Yes, that is 6. So we know 5 and 6 are factors. And if we went one more time, notice how these numbers are increasing. 1, 2, 3, 4, 5. The next one would be 6. So if we took 30 divided by 6, we get 5. And that would make it factors of 6 and 5. Since we've repeated it, that means we found all the factors. So therefore, we can say 1, 2, 3, 5, 6, 10, 15, and 30 are factors of 30. That would be our final answer. Now, to get all these numbers here, I simply just listed all of these numbers going in order from the smallest to the largest. And you could count these 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So that would be all the factors of 30. So what I would like you to do now is try out your turn part A. So pause the video, try it out, then unpause the video to check your answer. Go ahead. So from this, we can see the factors of 40 are 1, 2, 4, 5, 8, 10, 20, 40. Notice when I wrote these out, I kind of skipped a little step here. If I found it divided evenly, I just moved on to the next one. Again, make sure you go in order with your numbers of what you're dividing by. That way you don't miss any. And I found that 5 went into 48 times. And then when I tried 8, I got back to 5, so I started to repeat it. So then I just took all the values that went in evenly, I used the divisor and the quotient, and listed them in the factors. Now, I want to talk about one more example that isn't on this page. And that's going to be the one, let's say we have the number, let's go with 16. If we had to find all the factors of 16, we know that we could take 16 divided by 1, which would give us 1 and 16. We know 16 divided by 2 would give us 2 and 8. 16 divided by 3 doesn't work. 16 divided by 4, we know that 4 times 4 would be 16. But since 4 times 4 is just one number, that means we only list that 4 one time. You do not list two 4s because it's just one number. So therefore, the factors of 16 would be the 1, 2, 4, 8, and 16. Okay, let's move on to the next page. Objective B is to find the prime factorization of a number. A number is this is going to be a prime number. A number is a prime number if its only two different whole number factors are 1 in itself. For example, 7 is a prime number because its only factors are 1 and 7. If a number is not prime, it is called a composite number. Because 6 has factors of 2 and 3, 6 is a composite number. The number 1 is not considered a prime number, therefore it's not included in the set of prime numbers. Let's talk about that for a second. The reason why number 1 is not considered a prime, because you'd have to multiply 1 times 1 to get 1. A prime number states it has to have only two different whole number factors, whereas 1 times 1 is the same number. That's why it's not prime. Okay, let's look at the next thing here. It says the blank of a number is the expression of the numbers as a product of its prime factors. This is going to be prime factorization. So prime factorization is when you express a number as the product of its prime factors. You need to make sure you understand what prime factorization is. A product of its prime factors. For example, the number 6. We could rewrite 6 as 2 times 3. 2 and 3 are both prime numbers. Therefore, 2 times 3 would be the prime factorization of 6. And we see something, the next example right here. So with that idea, true or false, the prime factorization of 12 is 2 times 6. Well, we know that 2 times 6 is 12. 2 is prime, but is 6? No. So that means this would be false because 6 is not prime. Prime factorization can only have prime numbers. I'm going to work through I'll work through 2 here, or we'll go through 3 and then I'll let you do the other 3. So the first one, example 2, find the prime factorization of 60. There's multiple ways you can work through these problems. So I start by writing 60 with an equal sign. So what you want to do now is think of a factorization that gives you 60. What are two numbers you can multiply together to get 60? You can choose any of those. You could use 2 and 30. You could use 6 and 10. It doesn't matter. In the end, we'll get the same answer. I'm going to start with 2 times 30. Now we know 2 is prime, so I'm going to circle it. Then what I'm going to do is put another equal sign. Anything you had circle, write it again. Now we're going to change that 30 and rewrite that as a prime factorization. You could use 3 and 10. You could use 6 and 5. It doesn't matter what you use. I'm going to go with 6 and 5. And then you ask yourself, okay, are either of those prime? Well, I know my 5 is prime, and that 2 is still prime, so I put circles around them. Now, what we have to keep doing here is taking every number that's composite and do another level until we break everything down. So again, I rewrite what I have circled, that 2 times 5. Now I have to look at this 6. I can rewrite 6 as 2 times 3. Now I'll notice 2 is prime, 5, 2, everything is prime. Once everything is prime, we've found our prime factorization. Now we just need to write our answer correctly. And you can write this one of two ways. One way is you can list everything from smallest to largest. So 2 times 2 times 3 times 5. Or if we notice we have two 2's, we can write 2 squared times 3 times 5. Before you move on to the next one, though, what you should do is double check it using your calculator. Type whatever you're answering, whichever way you're writing it, type it into your calculator. If you type this in your calculator and you're not getting 60, you made a mistake somewhere. So whichever way you're answering it, make sure you check it in your calculator. Now, let's look at the next example. Find the prime factorization of 13. So we start with 13 equals. So we want to think, what can we multiply to give us 13? Right, the only thing we can think of is 1 times 13. Well, remember, since a number only has two different whole number factors, one in itself, that calls it a prime number. So therefore, 13, we're just going to write is prime. There isn't a prime factorization because it is prime. The last one we're going to do together is 36. So again, we start with 36. Now we have to find a factorization. We have lots of options here. We could use 4 times 9. We could use 6 times 6. It doesn't matter. I'm going to use the 4 times 9. And then neither of those are prime, but I know I can rewrite the 4 as 2 times 2, and I can rewrite 9 is 3 times 3. Now everything here is prime, so therefore I can have 2 squared times 3 squared. And if I'm answering with 2 squared times 3 squared, I want to type it in my calculator just as I'm writing the answer, just to make sure I don't have any mistakes. And when I type this in, I'm getting 36, so I know that is the correct prime factorization. Now what I'd like you to do is try the 3 your turn problems. When you're finished, unpause the video and check your answers with mine. Okay, you can see my answers here. The other thing I want to make note of is you'll notice how on all of them except for the primes, I'm showing work. You need to make sure you're showing some kind of work. How are you going from 90 to 2 times 3 squared times 5? Like I said, there's multiple ways you can do some of these, and I just want to show you another process for one of these. Let's say for 90 you used 30 times 3. You say, okay, 3 is prime, but we have to change 30. So I'm going to bring down that 3. Now 30 we can rewrite as 3 times 10. We know that 3 is prime, 3 is prime. So now the 10, we can change that to 3 times 3 times 2 times 5. So again, we're still getting the same answer here, but you have to make sure you show me what you are doing. Well, that completes the notes for this section. So make sure, as long as you don't have any questions and you feel confident about the material, go ahead and try the homework and then let me know if anything comes up. Thank you.